Chemistry 108 at York College. Today is March 3rd, 2015, and we're continuing on in Chapter 3. All right, so let's look at this problem here, as you've been looking at. How many O2 molecules are in 4.0 grams of oxygen? So, O2, molecular oxygen here. So let's, before we do any calculations, let's try to draw out a map or something. How are we going to set this, how are we going to conceptualize this? Yes, Mr. J.
4 grams of O2.
Before we do any math, let's think about conceptually, how are we going to get from this to this? Yes? We want to go first from grams to moles, and then from moles to molecules. And what are we going to use to get from grams to moles? We're going to use the molar mass. The molar mass has units of grams per mole. So we can use that. Remember, the molar mass is like the molecular weight, except the unit is grams per mole instead of AMU. Right? And when we have grams per mole, we can use this as a conversion factor, just like you use like centimeters over meters or inches over centimeters. We can cancel grams and get moles. Right, so we're going to use the molar mass. Once we have moles, how are we going to get to molecules? Avogadro's number. I'm going to use Avogadro's number. And that's going to be 6.022 times 10 to the 23rd, in this case, molecules per mole, right? Okay. So, how are we going to set this up? Yes, we should call you Dr. J. Yes, okay.
4 grams of O2.
4.0 grams of O2.
Times 1 mole over 32 grams of O2.
Okay, so what we're going to do is use the molar mass, right? So we're going to have O2, and so there's going to be 2 times 15.9994. Is there an extra 9? 3 nines, okay. And that's going to give me 31.9992, right? No. 9988. Okay, so if you round that to 32, in this case you're okay, but not always. Right? So you want to keep at least a couple of decimal places so you don't lose significant figures. So we're going to say, and what's the unit here? The unit is grams per mole. In English, what that means is 1 mole of O2 has a mass of this many grams. Right? Or in other words, 6.022 times 10 to the 23rd molecules of O2, which is 1 mole of O2, has that mass, 31.9988 grams. All right, so what we want to do is use this as a conversion factor. So we're going to do 31.9998 grams of O2 per mole of O2. Grams and grams cancel. And now we're going to get, when we do that, we get a certain number of moles of O2, right? I could stop here, except I don't really want to because I want to get from moles to molecules. How do I convert between moles and molecules? Yep.
You multiply by 6.02 times 10 to the 23 molecules over mole.
Right, so 6.022 times 10 to the 23rd molecules per mole. That's what Avogadro's number tells us. It's how many molecules for 1 mole, or how many anything, right? It could be a dozen eggs. It could be a mole of eggs. So the moles now is going to cancel with the moles. You can say moles of O2 and molecules of O2. And when I get the answer, I do 4 divided by this, multiplied by this, and I'm going to get, with limited by 2 significant figures, 7.5 times 10 to the 22nd molecules. Questions? Yes.
So when you do 4 divided by 31.9988,
Yeah.
you don't apply the significant figures there and then multiply?
You could, if you applied the significant figures here, you would get two significant figures.
But then I got 7.8 as the final answer.
It doesn't seem like it would be so that different. And check what you're putting into the calculator again. What do you get when you do this? 4.0 divided by 31.9988. 0.1250? Oh, I see what you're saying. Because you round this to 0.13. Yeah, okay, so then you might get 7.8. That's okay, right? I mean, yeah, that's okay. I mean, if you want, you can keep an extra figure or two as you're going across and then just round at the end. That'll give you kind of a more accurate result. But if you round at each step, I can't tell you that's wrong. Questions here? Really no questions here. So if I give you a pop quiz now, then you'll be just checking. Okay, so we'll take this one more step and then we'll do another problem. Okay, so same information. Now I'm going to say how many atoms of oxygen not molecules of O2, this is atoms of oxygen, just O. How can I do that?
The same as one, except you don't multiply with 15 there. You do 4.0 divided by 15.99.
Not quite. Because I have that many grams of O2. So you're thinking kind of the right way, but not completely. So you have that many grams of O2. So you have this many molecules of O2. How many molecules how many atoms of O are in one molecule of O2? How many atoms of oxygen are in a molecule of O2? 2. Yeah, you don't overthink it here, right? It's O2. That means there's 2 oxygens. Right, so if you have 7.5 times 10 to the 22 molecules of oxygen, O2 oxygen, molecular oxygen, we can say, I mean, this is a little bit silly here, but 1 molecule of O2 is equivalent to how many atoms of O? 2. 1 molecule of O2 has 2 atoms of O. No, because we already used Avogadro's number, right, to get the molecules. Now we're just saying, in this many molecules, how many atoms are there? Right, if it was O3, it would be 3. And so now we say 2 atoms of O. And then that's going to give us 1.5 times 10 to the 23rd atoms of O. Questions? Yes. This connects. You're really kind of learning a mathematical approach here, right? But what I don't want you to do is forget about chemistry, because this is a chemistry course, not a math course, right? So to do this, let's write this completely, right? How many atoms of oxygen in that? Right? So or in that. So this is basically asking if you understand what O2 means. Right? O2 means that in one molecule of oxygen, there's 2 atoms of oxygen. So if you had 10 molecules of O2, how many atoms of, let's take a step back, right? If you had 1 molecule of O2, how many atoms of O do you have? 2. If you have 10 molecules of O, how many atoms of O2 do you have? 10 molecules of O2, how many atoms of O? 20. Right? If you have 100 molecules of O2, you have 200 atoms, because each molecule has 2 atoms. So that's all we're doing. Each molecule, now we have a huge number of molecules. Each one has 2 atoms. Okay. Let's do one kind of just like it. If we have 4.5 grams of water. Yep, 4.5 grams of water. How many molecules of water do we have? And how many total atoms do we have? So total atoms, we're talking about H atoms plus O atoms. And so put your heads together again and give it a try. Okay, so first thing we're going to find out is, well, conceptually we're going to do the same thing, right? We're going to go now from grams of H2O, right, over to moles of H2O, over to molecules of H2O, and then we're going to have one more, which says atoms. Total atoms, or atoms total. To get from grams to moles, what are we going to do? What are we going to use? Molar mass. Molar mass has grams and moles in it. As we get from moles to molecules, what are we going to use? Avogadro's number. And as we get from the number of molecules to the atoms, we're basically just going to count, right? How many atoms in one molecule? This chalk is getting interesting. Okay, so the first thing we're going to use is molar mass. Right, what's the molar mass of H2O? What does the 2 refer to here? The 2 refers to the hydrogen. So we're going to take the hydrogen and we're going to multiply it by 2. And we're going to get 2.015, 16, I think, right? 16 grams per mole. And then we're going to get the plus O times 1, right? Equals 15.9994 grams per mole. And we're going to add that. We're going to get, what is it, 18.0 what? 09? 0098, 001, 010, right? Is that good? No. What's good? 0152. So 0152, but we can leave it here, 0 and 5 grams per mole. Okay. That's an 8, yes. That's not a very nice 8, but that's an 8. Okay. So where are we going to start? We're going to start with our 4.5 grams, right? 4.5 grams of H2O. Where are we going to go next? We're going to go to moles. And how are we going to do that? 1 mole over 18.015 grams. 1 mole of H2O, grams of H2O. Now what? Grams and grams cancel, and we got moles. What do we want to do with our moles now? Molecules. How are we going to do that? Avogadro's number, it's 10 to the 23rd. Molecules of O2 equals 1 mole of O2. Now we got molecules of O2. One more step here, right? We need to get from molecules of O2 to total atoms. How many atoms are in 1 molecule of O2? And that's not O2, it's H2O. H2O, right? There's 3 atoms. Where do we get 3 atoms? We get 2 H's plus 1 O equals 2H plus 1O equals 3 atoms. And so ultimately what we want to do is multiply whatever we get here by 3. I'm going to do it with units because I want you to use the units, right? So 1 molecule of O2, H2O, 1 molecule of H2O gives you 3 atoms. And when you do that out, so you get your molecules to cancel, it's going to be, I think you're getting 4.5 times 10 to the 23rd atoms. We happy here now? Happier? Good. Because we're going to keep on going. Yes. And you're just going to keep applying what you know here to more and more interesting and complicated problems. Remember this? Did we balance that in class? We did, right? So, okay, so when we balanced it, what did we get? We got, okay, so let's turn this back on. Can I erase? Okay, so we got, no, let's not do that one. Let's do a different one because we did this one already. Did we do the NH3 problem? Balancing problem? Yes, no? Okay, so, okay, fine. Doesn't matter, let's do it again. N2 plus H2 gives us NH3. Let's try to balance it. Any thoughts? 2 in front of the NH3. So that balances our N's. 3 in front of the H2. Are we happy now? We got 2 N's. 2 N's. How many H's? 6. How many H's? 6. Okay, so we're balanced. If we have 1 mole of N2, from that 1 mole of N2, we can make 2 moles of NH3. Right? If we have 10 moles of N2, how many moles of NH3 can we make? 20. If we have 3,000, how many can we make? 6,000. What are you doing? You're using, without formally doing it on paper, you're saying, okay, what does this 2 mean? This 2 means I get twice as much in terms of moles or molecules of this relative to this. If I have 1 mole of N2, how many moles of H2 do I need? 3. If I have 10 moles of N2, how many moles of H2 do I need? 30, right? And again, you're kind of intuiting 1 and 3, what these coefficients mean. If we wanted to formalize that, and sometimes it will be useful to formalize it, we can say something like this. We can say something like, I'm out of chalk. Let's say we have 3 no, let's say 0. If we have 0.3 moles of N2, we have all the H2 that we need. We're not thinking about the H2. How much NH3 can be produced? Well, you can do it in your head, probably, if you've been doing it in your head so far. If you can't, then, well, you still can't. What I'm going to do is I'm going to, whenever I'm looking at one product or reactant and asked about another one, I'm going to use the coefficients to get a mole ratio, right? So the coefficients give me a mole ratio. Another way I can look at it is the coefficients can be used as a conversion factor between to get from moles of A to moles of B, where A is one of your guys and B is another one of your guys. So what I'm going to say here is, because I'm given something about N2 and I'm asked something about NH3, is I'm going to say, pretend 1 here, right? 1 mole of N2. It's not really equals, right? It's not right to say it equals, but it's somehow equivalent to 2 moles of NH3, right? 1 mole of N2 produces 2 moles of NH3. And I'm going to use these 2 items as a conversion factor, just like I used 100 centimeters as a meter, just like I used 1,000 grams as a kilogram. And I'm going to say 0.3 moles of N2, and I want to convert that to moles of NH3. So because it's not saying it's equals is kind of implying they're the same thing. They're not really the same, exactly the same thing, but one produces the other. One comes from the other. So 0.3 moles of N2, and I'm going to use this as my conversion factor. So I'm going to say 1 mole of N2 gives me 2 moles of NH3. The moles of N2 and the moles of N2 cancel, and I'm left with moles of NH3. And that's going to give me 0.6 moles of NH3. Questions here? So far, so good? Let's do another one. I would like to produce ten 0.0 moles of NH3. How much H2 do I need? And let's say how much in terms of moles of H2 do I need? And how do you do that?
10 divided by 2 is 5.
Good. So we're going to set it up 10.0 moles of NH3. Even though that's what I want, that still is the given. Right? 10.0 moles of NH3. And what am I going to use as my conversion? I'm going to use the coefficient on the NH3, which is 2, and the coefficient on the H2, which is 3. And so this is the given, and this is the coefficients. And what goes where? On the bottom goes NH3, because I want the NH3 to cancel with the NH3, which is 2, right? 2 moles of NH3. In order to make them, I need how much H2? 3 moles of H2. So my moles of NH3 and my moles of NH3 cancel, and I get moles of H2. And when I do that, I did get 10 times 3 divided by 2, which is 15.0 moles of H2. Questions here?
So the equation always has to be balanced. It has to be equal to the
Correct. The equation must be balanced. So do we need to do another one of these, or can I move on to something harder? What? Let's do both at the same time. Okay. So let's say instead of saying how much H2 do I need in moles, I said how much H2 do I need now in grams. What can I do? Exactly. I would take the moles here and convert it to grams. Do you know how to do that? Molar mass. It's the same as 3 boards ago. And so the molar mass of H2, if I recall correctly, is 2.016. Right? H2 has a molar mass of grams per mole. And so I would take my 15.0 moles of H2 and go do this, right? 2.016 grams per mole, grams of H2 per mole of H2, and I would get 30.2, right? 30.2 grams of H2. Let's do another one before we take a break. If I have, starting with 3.5 grams of N2. How many moles of NH3 can be produced? Okay, so put your heads together gently and give it a shot. Remember, now you're starting with grams. And the coefficients deal with moles. So what are you going to have to do? Convert grams to moles. And you know how to do that. Oh, okay, so the molar mass of N, it's the molar mass of N. It's 14 point something. 007. So N has a molar mass of 14.007 grams per mole. But remember, it's not N we're interested in, it's N2. So, in order to get, let's map this out again, right? So we're going to start with grams of N2, and then from grams of N2, what do we want to do? Moles of N2, right? Once I get from moles of N2, I want to go to moles of NH3. And so in order to get from grams to moles, I'm going to use the molar mass of N2. And in order to get from moles of N2 to NH3, I'm going to use the coefficients. So to get N2, I'm going to say that each N is 14.007 grams per mole. N2 has two of them, and that's going to give me 28.014 grams per mole. Really low on chalk here. Okay. I'm going to start with my given. My given is 3.5 grams of N2, right? So 3.5 grams of N2, and I'm going to want to make that into moles of N2. And the moles of N2 is going to come from here. That's 28, right? It's going to be 28.014 grams of N2, because I want the grams and grams to cancel, per mole of N2. So the grams and the grams of N2 cancel. I have moles of N2 now. Now I'm going to use my N2 coefficient and my NH3 coefficient. So I'm going to say 1 mole of N2 is going to give me 2 moles of NH3. And I'm going to get from moles of N2 to moles of NH3. And the answer is going to be 0.25 moles of NH3. Questions? Which part? Last? Okay. So if I were to do this divided by this, I would get 0.125, I think, moles of N2. Now, if I have a number for moles of N2, you're the one telling me that if I have like 0.3 moles here, I'm going to get 0.6 moles here. You did that because it's 2 to 1. So once I get some number for moles of N2, I just do the same thing, right? 2 for 1. 2 times 1. which is what we're doing here, 2 moles of NH3, is equivalent in this reaction to 1 mole of N2. And I multiply whatever I get here by 2, and I get 0.25.
What did you get for the, how many moles of N2 are in 3.5 grams of it?
0.125? Yeah. So 0.125 times 2 is going to give me 0.25. I mean, if you round it off here, it would be 0.12, or I guess, and then you'd get 0.24. But okay, let's take 10 minutes. Yep. All right, let's do this. So if we have, let's say, 1.5 grams of H2. We start with 1.5 grams of H2. How many NH3 molecules can be produced? There's a point here. The point is, you can do anything with anything. And you should be able to do it, right? So let's say from 1.5 grams of H2, how many NH3 molecules can be produced? Give it a shot. Now put your heads together gently. Okay, so what do we need to do? So we need to go, from grams of H2 to, go from grams of H2 to moles of H2 to what? Moles of NH3 to molecules of NH3. So for here, we're going to use molar mass. For this one, we're going to use the coefficients. And for this one, we're going to use, what are we going to use here? Avogadro's number, right? Avogadro's number gets us to molecules. H2, we calculated that, right, so 2 times H2, 2 times 1.0079 equals 2.016, right? 158? Yeah, 158 grams per mole. We're going to be limited by 2 significant figures, so not super important. The very end is not going to affect us much. We're going to have 1.5 grams of H2. We're going to go from grams to moles using molar mass, right? 2.0158 grams of H2 per mole of H2. Grams and grams will cancel. Moles of H2 to moles of NH3. We're going to use the coefficients here, right? So 3 moles of H2 give us 2 moles of NH3. So now we have moles of NH3. And then we're going to use 1 mole of NH3 equals 6.022 times 10 to the 23rd molecules of NH3. And if I'm correct, we're going to get 3.0 times 10 to the 23rd molecules of NH3. Questions here? So far, what have we learned? We've learned molar masses, molecular weights. We've learned balancing equations. We've learned moles, Avogadro's number. We've learned how to use the coefficients. And putting that all together, we can do lots of calculations, right? Thinking about products and reactants quantitatively. Now, we're going to take that even one step further. We'll keep the same reaction, just because. And we're going to move on to a topic called limiting reactants. Limiting reactants is kind of the same, but there's a lot of moving parts, so you have to keep them straight. Let's say, same equation, right? Same reaction. If I mix 1.0 moles of N2 and 2.0 moles of H2. This is something new, right? So far we've just been looking at one reactant at a time. Then I'm going to say how much is the maximum amount of how much ammonia can be produced. Now, how can I figure this? And the question is, well, do I use the N2 or do I use the H2? Both. And I'm going to see which one runs out first. Because if I didn't set it up just exactly right, one of them is going to run out. Right? If I say I have a bag of 5 hot dog buns, and I have a package of 8 hot dogs, how many people can I serve? Well, I'm going to run out of buns before I run out of hot dogs. Right? So I can only serve 5 people, and I'm going to have some leftover hot dogs. Same thing here. I have a certain amount of buns and a certain amount of hot dogs. One of them is going to run out first. I don't know which one just yet. But I'm going to see how much NH3 could be made from the N2. And I'm also going to see how much NH3 could be made from the H2. I know how to do this, and I know how to do this. And my answer here can be in moles, no problem. I don't have to do anything more. So I'm going to say 1.0 moles of N2. And then I'm going to find out how much NH3 I could use, right? So I'm going to use 1 mole of N2. Gives me 2 moles of NH3. And that's going to get me 2.0 moles of NH3 can be made. Or can be produced from the N2. I'm going to do the same thing now for the H2. And the H2 I'm starting with 2, right? So 2.0 moles of H2, that's what I'm given. right? And then I'm going to say now, what goes here? Sorry? Yeah, H2. So 3 moles of H2 can produce how many moles of NH3? 2 moles of NH3. And when I do that, I'm going to get 1.3 moles of NH3 can be produced from N2. From H2. So let's think about it here, right? Let's say I have, I'm not drawing very well, right? But 5 hot dog buns, 8 hot dogs. Right, how many complete servings can I make from the buns? 5. How many complete servings could I make from the hot dogs? 8. Right, I mean, ignoring the buns. Right, I could make 8. How many complete servings can I make from this? Because you ran out of buns. Because you could make 5, when you did the calculation like this, you got fewer complete products from the buns. Here, you get fewer complete products or less complete product from the hydrogen. So here, your limiting ingredient, what prevents you from making more, is the buns. Here, your limiting reactant is the one that smaller runs out first. So this is the limiting, called the limiting reactant. And because it makes less product, less product is possible. It runs out first. Sorry, there's a question?
So you could only make 1.3 moles.
So you can, correct, you can only make 1.3 moles of NH3. Only 1.3 moles of NH3 can be made. Questions here? Is it going to get more interesting? Yes, it will, but not just yet. We're going to keep the same level of interest and do another one. So here's your equation. And let's say we have 2.5 moles of N2 and 9.0 moles of H2. And the question is going to be, how much NH3 can be produced? You try it. we're going to ask, do we get less product from the buns or less product from the hot dogs, right? So 2.5 moles of NH3 well, let's write it out. How much NH3 can be made from N2? And so we're going to do 2.5 moles of N2, and then we're going to use the coefficients, and we're going to say 1 N2 gives us 2 NH3, right? 1 mole of N2, and that's going to give me a total of 5.0 moles of NH3 could be made from N2. Then I'm also going to ask how much NH3. Now, once you've gotten the hang of this, you don't have to write out how much blah, blah, blah. But for now, we're going to do that. How much NH3 can be made from H2? Well, we're going to start with 9. And then we're going to use our coefficients. 3 moles of H2 gives us 2 moles of N2. Right, those cross. We got, nope, NH3. And we get 2 moles of NH3 can be made from 3 moles of H2. And we're going to get 6 moles of NH3 from H2. This one gives you five complete servings of hot dog. This one gives you 6 complete servings of hot dog. Which one runs out first? 5. So the limiting reactant, therefore, is N2, limiting reactant. And how much NH3 can be made? This much. Questions? Now, what I want you to do by Thursday, if you can, is try to figure out, okay, so this one ran out first, right? That means we used all of the N2. That also means we didn't use all of the H2. There's some leftover, right? There's some leftover pink. How much H2 is left over? How much H2 is left over? This is called our excess reactant or reagent. So how much excess is left over? We're going to stop here and give back the tests, but this is where we'll pick up and give it a try. Not quite, because you have the scaling factor somehow. Right? What you would want to do is go back and find out this requires how much this. Does that make sense? And then subtract. All right.